Hi folks, we're going to take a look at number 16 from page 107. So we've got this limit here. So first thing we should do is see if there are any problems with it. If not, we can just input the value of x. So we put in x equals 0 here, and we get root 1 minus, and this is also root 1, so we've got a 0. The numerator is approaching 0. And if we look at the denominator, we've got square root of 4 minus, again, square root of 4. So the numerator and denominator are both approaching 0. So we have an indeterminate form, hence we've got to do a little more investigation to see if this limit actually exists. Now again, as soon as you see square roots, especially when there's another term that's being subtracted, you should be thinking about rationalizing. Okay, so if let's put brackets around everything. So if I multiply numerator and denominator by x, root x plus 1, this time plus root 2x plus 1 over root x plus 1 plus root 2x plus 1. Okay, I'll end up getting rid of these square roots in the numerator, so I'll be able to do some algebra there. The problem is that I'm still going to have this expression in the denominator, which gives me 0. Which again I can't do any algebra with. So this is where, this is why this is in the extending section, we have to think a little beyond what we were doing before. So why don't we rationalize the denominator also, so that we can then simplify it and hopefully do some algebra and see if things work out. Okay, so that's the trick here, is realizing that you have to rationalize both the denominator and the numerator. Okay, so I'm going to multiply numerator and denominator by the conjugate of the denominator, so root 3x plus 4 plus root 2x plus 4. Okay, so now if we take this first multiplication here, we just have our difference of squares, so this is going to be x plus 1 minus 2x plus 1. Okay, plus I'll have this expression here, but this isn't a problem now in the numerator because this is not going to be approaching 0. So we have root 3x plus 4 plus root 2x plus 4. And I should put brackets around that there. And in the denominator, I'm going to multiply these two here to give us a difference of squares. So we're left with 3x plus 4 and then minus 2x plus 4. Okay, but of course we still have this term here, which again doesn't pose a problem because it does not approach 0 as x approaches 0. Okay, and now let's go ahead and see if we can simplify here. And so what we're left with in the numerator is x minus 2x. So negative x, and 1 minus 1 is 0. So that simplifies quite nicely. And in the denominator we have 3x minus 2x, so x, and 4 minus 4, so again 0. So again simplifies very nicely, and here we're left with x plus 1 plus root 2x plus 1, and now we can simplify numerator and denominator. And what we're left with is an expression where the denominator does not approach 0 anymore, hence we can just evaluate the limit by inputting the value that x is approaching. Okay, so in the numerator we've got 3x and 2x will both approach 0. So I've got square root of 4 plus square root of 4, so 2 plus 2 is 4, so that's negative 4. And then in the denominator, this x is approaching 0, so this is approaching root 1. This is also approaching root 1, so 1 plus 1 is 2. And we're left with a final answer, of negative 2. Okay, went a little too quick there. Okay, so, and I believe the answer in the back of the book is incorrect. I think that they have positive 2 as the answer, but here clearly it should be negative 2. So just a quick recap here. The important thing was to first of all realize that we had a indeterminate form, and then to realize that just rationalizing the numerator wasn't going to be enough because we were still left with this expression approaching 0 in the denominator, which we couldn't do much algebra on. Okay, so we solved that problem by also rationalizing the denominator. So again, it's the same types of tools that we're using, sometimes in slightly different ways than we did before. Okay, that's it.